Hello and welcome to lesson 1.3. We're going to talk about the properties of numbers. These properties of numbers are essentially what allow us to do anything in algebra, anything in computational math, anything in theoretical math. These are the backbones of math, of numbers. These are the properties of numbers. So what we're going to go through today is we're going to go through the property, we're going to define each property or state it theoretically, and then give a couple of examples. Not the most exciting thing, to be honest. There's some more exciting stuff down the line, but it's really important that we understand why we do what we can do. So we're going to start right off with the reflexive property. The reflexive property essentially says that any quantity is equal to itself. Any quantity is equal to itself. So if we defined it and put it in symbols, for any value a equals a equals itself. So we could say 4 equals 4, but we can also go ahead and say, 3 plus 7 is equal to the exact same thing. It's equal to 3 plus 7. So we can think of the reflexive property as equals self. Reflexive property for anything, a equals a. Pretty easy. The symmetric property. For the symmetric property, we say that if a first quantity equals a second quantity, then that second quantity equals the first quantity. So for any value a and b, if a equals b, then b equals a. So for example, if 8 equals 2 plus 6, if 8 equals 2 plus 6, then 2 plus 6 equals 8. I like to think of this as the mirror. So we see that if a equals b, then b equals a. We took what was there, like 8 equals 2 plus 6, and we mirrored it. We flipped it over, that equal sign. It's symmetric. Like if we took two things and folded it and then switched it, we'd be left with the same thing on either side. The transitive property. The transitive property we probably all know and we've used in reasoning a lot. The transitive property says that if one quantity equals a second quantity, and if that second quantity equals a third quantity, then that first quantity equals that third quantity. So if a equals b and b equals c, then a equals c. So if 6 plus 9 is the same thing as 3 plus 12, and we know that 3 plus 12 is equal to 15, then we know that 6 plus 9 is also equal to 15. So again, if one thing equals a second thing, and that second thing equals a third thing, then that first thing does equal that third thing. That's the transitive property. We've used it a lot. Now we just have a name for it. All right, moving on to the substitution property. The substitution property says that a quantity can be substituted for something equal to itself. So if a equals b, then a can replace b. So this one's kind of tricky, and so if you think, let's look at this. I have two different examples that I want to share. So one of them is if n equals 11, then 4n is equal to 4 times 11. That's one example that we can think of. Since we know that n equals 11, we can plug n equals 11 in for n to make 4 times 11. Another thing that substitution is kind of just, as I like to call, doing the math. So for example, if we think 3 plus 6 equals 9, that's substitution right there. We know that 3 plus 6 and 9 equal each other, so we can set them equal to each other. So I'm going to call this like plug in, like plugging things in that we know, as well as also kind of doing the math. All right? So these four, since they all deal with equality, these are all properties of equality. We didn't really do anything with addition or subtraction. We just said this equals that, so therefore this equals that. These are all the properties of equality. All right, let's move on. So we're going to look at the additive identity next. The additive identity says that for any number, the sum of that number and 0 is that number. So essentially, a plus 0 equals that number, a, or 0 plus that number is equal to that number. So for example, 4 plus 0 equals 4, just as 0 plus, let's say, 17 equals 17. With the additive inverse says that a number and its opposite are the additive inverses of each other. So a way to visualize this is if we think we take a number, b, and add its opposite, negative b, we're going to get to 0. So for example, let's say 3 plus negative 3 is equal to 0. We could also think of this kind of as subtraction. Subtracting one number minus itself equals 0. So we could say 7 minus 7, which is really 7 plus negative 7, is equal to 0. And these two are addition properties. Let's look at some multiplication properties. So we have the multiplicative identity, or the multiplication identity. If the additive identity says that if the additive identity's goal was to get the original number plus something to equal that original number. So for the multiplicative identity, we're going to look at what can we multiply a number by to be left with that same number. And the multiplicative identity is 1. So the multiplicative identity is saying for any number, the product of that number and 1 is that number. So we could say that 14 times 1 is equal to 14. Or we could say, 1 times 300 equals 300. That's our multiplicative identity. Anything times 1 is equal to that number that we put in. The multiplicative property of 0. This is something that when we started our times tables back in 2nd, 3rd, 4th grade, whenever that was for you, that is that first row of the times table that we did. Pretty much saying that any number, we'll say C, any number times 0 is going to be 0. Whichever order you put it in, any number times 0 is 0. So we could say that 9 times 0 is equal to 0. We could say 24, we'll put 0 first this time. 0 times 24 is equal to 0 as well. So anything times 0 equals 0. That's formally known as the multiplicative property of 0. Our last multiplication property is the multiplicative inverse. So for the multiplicative inverse, we're saying that every number that does not have a denominator of 0, so this can be fractions as well, every number, for every number there's exactly another number such that when you multiply them together, you get 1. So it's saying that if you have a number a over b, let's say that a over b could be a whole number just written as a fraction, could be written as a rational number. So for any number times a specific number, there exists a specific number for every number such that when you multiply them together, it's 1. You could also maybe see this as if you have a number and you multiply it by 1 over that number, you're going to be left with 1. So let's say, if there's 2/3, we can multiply that by 3/2 and we get 1. We take that fraction and we flip it upside down and we're left with 1. Or if we have a whole number, let's say we have y. Let's say we have 4. If we take 4 and we flip it over, so we take 4 over 1 and flip it, so then we have times 1 over 4, that'll leave us with 1. That's the multiplicative inverse. Pretty much saying that you can multiply any number by its inverse, and that'll leave you with 1. And again, these three properties here, we have the multiplication properties. All right, we have three more properties, to look at today. 3 more properties. We have the commutative property. The commutative property says that the order in which you add or multiply numbers does not change the sum or product. So the commutative, we talk about order, and essentially say that a plus b is the same as b plus a. And also, like x times y is equal to y times x. So for example, 4 plus 8 is the same thing as 8 plus 4. And 7 times 3 is equal to the same thing as 3 times 7. Now be careful. I'm going to challenge you to go back and look at what's the difference between the commutative property and the symmetry property. The commutative property and the symmetry property. They're both different. They might look the same. They might look very similar, but they are very different. They're very different. And commutative property also has 2 subproperties. There's a commutative property of addition, which is when you're dealing with addition, and the commutative property of multiplication. And then we have the associative property. The associative property deals with grouping. So this says that the way that you group 3 or more numbers when adding or multiplying doesn't change the sum or the product. So we could have a plus b plus c, and that is equal to a plus b plus c. Or we could take x times y times z, and that is equal to x times y times z. So for example, if we did 3 plus 5 plus 7, that's equal to 3 plus 5 plus 7. That's your additive associative property. Or we could look at 2 times 6 times 9, and that's the same as 2 times 6 times 9, and that's your associative property of multiplication. So think of associative property as changing where your grouping symbol goes. You can group these first 2, you can group the second 2, but so long as it's all multiplication or it's all addition, it doesn't matter which order it goes in. Last but not least, we're going to quickly look at the distributive property. We're going to focus a lot more on the distributive property in our next lesson, actually. We're going to just focus on the distributive property all the way, but I wanted to introduce it now as it falls in this list of properties. The distributive property says that if you have, let's say, A times a group B plus C, if you have multiplication and addition together, the result is that you took A times B plus A times C. So for example, if you have 3 times 2 plus 4, that is equal to 3 times 2 plus 3 times 4. Alright? That is equal to 3 times 2 plus 3 times 4. Alright? So here are our properties. Let's see if we can do a little bit with identifying between these commutative and associative property real quick. Alright, our homework, our practice problems. You're going to look on my class website, and I'll post a link with it. You'll find there's a worksheet called Properties Worksheet. Properties Worksheet. In this Properties Worksheet, there are 16 examples of some of the properties that we went over. Some of them will not be used at all. Some of the properties in our chart that we just made. Some of the properties may be used twice. Careful to, say, if this is multiplication associative or addition commutative, or this is the additive identity or the multiplicative inverse. So for example, we see this first one, number 1, is 4 plus 9 is equal to 9 plus 4. So if we think of that, what changed? 4 plus 9, 9 plus 4. We changed the order. So if we think order, that's going to be the commutative property. And since commutative property has addition and subtraction, we're going to make sure we say commutative property of addition. Yes, I want you to say of addition, of multiplication. Identify if it's the multiplicative inverse, additive inverse, alright? So there's number 1, and we're going to box this so that we know it's our solution. We're going to skip a line, write our original for number 2, which is 2 times 1/2 equals 1, and we'll identify the property. Have fun. Good luck.